Hello everyone, I am Dr. Sudhan Sharma from School of Computer Information Sciences, Indira Gandhi National Open University. In the past sessions, we had completed our block 1, that is Algebra 1, and since Algebra is a detailed topic, in Algebra 1, we had already covered about the determinants, we had covered about matrices, and we also covered the topic principle of mathematical inductions. Now, extending the discussion about algebra, we are going to firstly understand about what are the other topics which are quite relevant from the field of computer science for understanding in algebra 2. Now, this algebra 2, that is covering block 2 of our basic mathematics course BCS 012, is actually covering 4 units. Unit 1 relates to sequences and series. Apart from this, unit 2 of this block is about complex number, unit 3 is equations, and unit 4 is inequalities. In unit 1, we are going to understand what do we mean by sequences and how sequences are different from series. Apart from this, we are going to understand about different type of progressions like arithmetic progressions, geometric progression, harmonic progression, arithmetic geometric progressions, and also we are going to learn about to find the formula for some of the n terms of an arithmetic progression and some of first and natural numbers, their squares and cubes. This topic is going to be very interesting and it is a very essential topic from the point of view of computer science is concerned. The definition of computer program is sequence of execution of instructions. So, sequence of execution instructions, so you will better understand what do we mean by sequence by covering this unit. Actually, sequence is ordered list of the number that follows a particular rule. And what do we mean by series? Series is sum of the terms of a sequence. So, this is the fundamental difference in between sequence and series, that sequence is an ordered list of number that follows a particular rule and series is the sum of the terms of a sequence. And each number in the sequence is called term, and sequence can be finite or infinite, and wherein the finite sequence has the limited number of terms and an infinite sequences can have extended indefinite number of terms. Sequences can be classified on the basis of the rules for generating the terms. Likewise, we are having an arithmetic sequence, geometric sequence, harmonic sequence, Fibonacci sequence, and many more are there following a specific rule for the term generation. Now, we had already discussed that series is the sum of the terms of a sequence, and if we add the first n terms of a sequence, then we are getting a finite series, and if we are going to sum for an infinite sequence, then we are getting an infinite series. Now, sequence and series are having n number of applications, and they are very important in calculus, algebra, mathematical analysis, and many more areas which are related to computer science and other disciplines like physics, chemistry, and many more. So, we need to understand about we can apply this concept by understanding say limits for the convergence of the functions and many more areas in the advanced mathematics. So far as the computer science and algorithms is concerned, algorithmic efficiency, big O notations are frequently using the concept of sequence and series, wherein sequence and series are used to measure the efficiency of the algorithm, especially through the asymptotic analysis, wherein the series helps in analyzing time complexity and especially in the recursive algorithms. Recursive algorithms are those algorithms wherein the function calls itself. So, we will learn when we are going to understand about the topic of the algorithm, that what are iterative functions and iterative algorithms, how they are different from recursive algorithm, how to calculate the time and space complexity of the iterative algorithm and the recursive algorithm. Nonetheless, data compression, signal processing are also explicitly using the sequence based transformations such as discrete cosine transformation, and the data compression algorithms are frequently using the concept of sequence and series. Other area of domain is finance and economics, wherein interest calculation and stock market analysis are heavily using the concept of sequence and series. In interest calculation, the geometric series are frequently used to model the interest, especially when we are going to calculate the compounding factor and the annuities. Apart from this, future values and present values in the financial mathematics are often based on the series value. Now, in the stock market analysis, the moving averages is a very important concept which is based on the sequences, and they are used to smooth out the price trends and forecast the stock prices. Nonetheless, in the coding theory and the cryptography, the pseudo-random sequence and error detection correction also explicitly use the concepts of sequence and series. These examples are actually made to motivate you so that don't understand and estimate this concept of sequence series. It has got wide number of applications, and so that you are motivated towards this unit. That's why we are citing you the examples. The another important unit is your complex number, and in this unit we are going to understand what complex numbers are. Apart from this, we are going to learn about the algebra of complex number and understand the concept of conjugate and modulus of complex number. Further, we are going to learn about how to represent the complex number as points in a plane, that is in the polar form of a complex number, and then we are also supposed to learn about the power of the complex number, how to find the exponential value for a complex number, and finally the unit sums up with the understanding of the de Moivre's theorem. Complex numbers are the numbers which are having the two parts, that is a real number and the imaginary number. Likewise, over here we are given the number z is equal to a plus bi, where I is the complex number, is the imaginary number, and this part is the real number. So, b is the coefficient. Complex number is typically represent z is equal to a plus bi, where a is the real part and b is the imaginary part. Now, if we want to understand it from the point of the coordinate geometry, say we are having an xy plane, then z is equal to x plus iy is in fact a complex number. So, any point xy, the y part, the y axis represents the complex plane, part, imaginary part, and x component represent the real part. So, any number x comma y can be written by a complex number z is equal to x plus iy. So, this is about the visualization of the complex number. So, in algebra the complex number is written by z is equal to x plus iy. So, horizontal axis represent the real part and the vertical axis represent the imaginary part. Actually, in mathematics this complex numbers concept is extended to extend the concept of real number by adding a new element I, and which is an imaginary unit, and I square is actually represented by -1. That means we need to say that I is square root of -1. This number is iota, this is iota, and this is complex number. This is supposed to represent the imaginary part. So, this is about the complex number. So far as its polar representation is concerned, we are going to understand about the Euler's formula, wherein we are supposed to understand that, say, if we are having an xy coordinate system, the point xy in normal it is x plus iy, but for any line which is subtending an angle theta on x axis, then the polar representation will be given by cos theta plus iota sin theta, which is nothing but the Euler's formula or the polar representation of the complex number. This complex number, the concept is very essential from the field of say signal processing, wherein the concept of engineering, physics and applied mathematics are explicitly used, and it is very much important when we are going to work with the areas like waves, oscillations, electrical circuits, and very fruitful signal processing and digital image processing also. So, in the next unit after completing complex numbers is your equations, wherein we are going to understand about the quadratic equations and how to solve the quadratic equations. We are also going to learn about quadratic formula, and thereafter finally the unit sums up with the understanding of cubic and biquadratic equations. Now, equations, as you all know, that they are actually the mathematical formulation, and by solving those equations, we can find the actual values of the factors which are involved in the development of that equation. In the earlier sessions, we learned about the solution of linear equations, wherein we use the concept of matrices to solve the system of linear equation. I hope you remember we solved that the expression Ax is equal to B, wherein x is equal to A inverse B, and we wherein x is the solution of all the variables which are to be evaluated for the system of linear equations. Now, if we say Ax plus B y plus cz is equal to d, then all the powers, all the exponents of variable x, y, z are 1. So, that is why this is a system of linear equation, because the power is only 1. But if we say ax square plus bx plus c is equal to say 0, then maximum power is 2, and such type of equations are quadratic equations. We will learn about quadratic equations in more details. Apart from this, if we say ax cube plus bx square plus cx plus d equal to 0, and maximum power is 3, then such equations are cubic equations. They are widely used in various fields to model the relationships, to predict the outcomes, and analyze a system where the relations are not linear. And both type of equations are very essential in mathematics, and we will take different cases wherein we are going to solve about the quadratic and the cubic equation. The final unit of this block is inequalities. In fact, solving linear inequalities is the prime concern of this unit, and we will learn about the inequalities and the absolute values. Inequalities in the two variables are also delivered in this unit. Apart from this, there is a procedure to graph the solution of the set of linear inequalities in two variables. We are also going to learn about the system of linear inequalities in two variables, and thereafter the unit sums up with the evaluation of quadratic and non-linear inequalities. Inequalities are very essential in modeling the realistic constraints, and they are involved in various disciplines, because in general the world is not linear, it is not simple, the things are not equal. So, inequalities are very important from the point of view wherein there are constraints, there are ranges, we are supposed to find the situations wherein the expression holds true or not, or whether the expression fails. We are supposed to find the bounds of the expression wherein the expression holds true. So, there are very many applications so far as the inequalities are concerned. Some of the applications are optimization problems, wherein the inequalities are centered in optimization part. We are going to explore this concept of inequalities in when we are going to understand the concept of linear programming, which is one of the promising tools for optimization, which is an explicit optimization technique. And it is commonly used when we are going to solve the problems, likewise to maximize the profit or to minimize the cost or to optimize the resource allocation. Apart from this, understanding of inequalities is very much required when we are going to other areas, likewise economics, engineering, logistics, geometries, wherein we are going to understand about the convex and concave type of geometries, statistics and probabilities, wherein the Chebyshev and Markovian inequalities are very much required to understand for the prediction point of view. I hope you will enjoy content which is delivered in this block. You are required to go through the self-learning material which is available in block 2, that is Algebra-II, and we are going to solve the problems. We are going to deliver the sessions for better understanding, and now the next session will be about the unit 1, that is sequence and series. I expect you all to watch that session and apply the problems given in the unit for better understanding. Thank you.